that you're definitely going to come across a whole lot of in part 2, okay? Because you're going to be looking at this norepinephrine, epinephrine. Which one is it again, Greg?
Cortisol.
Cortisol. What do you think? You're going to look at those a lot, okay, in part 2. Well, what we need, okay, we need for these ones that can be released. One of the things that will happen, these are going to be chemicals that can get into the bloodstream. And that's one of the reasons that it's so difficult. Once something has gotten that fight or flight started, okay, and that could be good or bad, okay? It could be a happy event, it could be a sad event, okay, that will get that fight or flight going. But the problem is, these chemicals go into the bloodstream, and therefore they'll have a lot of contact with a lot of cells, all right, meaning heart rate, blood pressure, breathing, all these things that are going to happen, okay, they have to wait till they get all the way to the liver to get broken down. So, depending on what type it is, it can have a quick breakdown, stimulate usually at a very local point, or it can be something that's going to be widespread throughout the body and cause lots of areas of the body to react. So, the removal, well, like I said, for the acetylcholine, we've got the acetylcholinesterase, breaks it down. Acetic acid, the acetyl portion, simply goes back out into the blood. Choline goes back into the neuron. Norepinephrine, well, we're going to get the release, all right, go to the neurotransmitter, stimulate the cell in the case where people have MAOs, okay? We're hopefully going to see it either get taken back up into the neuron or a small portion released into the bloodstream, okay? For people that don't, okay, they're going to see all of this norepinephrine go into the bloodstream, all right? And what's going to happen? These people are going to have to be adrenaline junkies everywhere, okay? They're going to be those little daredevils all over the place, all right? So MAO inhibitors, like I told my husband, I said, you have no MAO inhibitors, do you? Well, I don't know, what does that mean? And I was like, okay, well, first of all, you go up in that little bucket, okay, like 200 feet up in the air with a welding machine and weld on stuff while swinging in the air. And you're not throwing up over the side of the bucket. And he was like, oh yeah, I do that. And so, to go to our house now, one of the ways we can go, we can always pass by King's Dominion. Well, the other day we stopped across from, King's Dominion at a little Exxon station so we could get gas. Well, that left me with clear shot of, I don't know what that roller coaster is. Alright? All I know is they were, I guess, putting it through some little trial run. Alright? And I'm sitting there and I'm watching that the little train of cars, whatever they're called, okay, going up and down and around and all that, and I'm like, and I'm sitting down, okay, and he was like, oh man, doesn't that look like fun? No. And he said, oh, look over there, there's the drop zone. I'm like, oh, that's so much fun. Okay, so you have to know, right? Oh, here. Okay, and I'm like, okay. There's my point. Okay. So, if you got that, hopefully it's going to help. If you don't, they're going to be adrenaline junkies. So, here's what's going to happen. When we get the release and we meet the postsynaptic and we determine, is it excitatory or is it inhibitory? Like the name implies, if it's excitatory and it's passing that transmission, we're going to keep, for the most part, an action potential going. Does that make sense? If the job of that chemical getting released is to make the next cell not function, what do you see happening if it's inhibitory? What does it do to the sensitivity of the cell that it's touching? Okay? It is, and it makes it hyperpolarized more. Do you guys remember when we were talking about how if we get the stimulus, makes it go to threshold, it's going to respond, then it's going to move back down, and for the nerve cells, they hyperpolarize. Do you remember why they hyperpolarize? So that the firing, we could get a little bit of a break and a little bit of recovery, okay? In the case of an inhibitory stimulus, the goal, where hyperpolarization might have taken it down to minus 90, let's take it to minus 110. Let's make it even more difficult for that cell to fire an action potential. And at that point, we have inhibited the response. So excitatory and inhibitory are both important in the nervous system. When those stimuli are coming into the cell, one of the things that I mentioned, if I had one stimulus come in, and then a second one, and a third, and a fourth, if I have all of that stimulus coming in, they add up, and therefore they summate. Do you guys remember summation? Now, in the case of a nerve cell, because remember, it's different with the muscle fibers. It was adding fiber, 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 fiber. And the more fibers that added together would make the contraction. All right? With the nerve cell has connections to it from thousands of other neurons. So, those stimuli coming in, all right, they summate. So if these are the dendrites of one nerve cell, think of these as dendrite, body, axon. Okay? I'm going to have terminal ends from thousands of other neurons coming in to this one neuron. It actually takes a lot to make a neuron fire. But, hey, they're busy all the time. Okay? So, we have our types of summation that can occur. There are different types. Okay? One type of summation, if it is considered temporal, pretty much the action potentials are coming in one right after the other. Note, action potential, okay? So it would be like boom, 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 coming in at this one point. If I were to get enough of that type of activity, do you think that that action potential could now make it across the body? If I got enough, okay, at that one spot, I could affect all the way across my nerve cell body. Because the goal to make it fire is to get it right here. Do you guys remember the trigger zone? It contains my axon hillock, and my axon hillock has tons and tons of what type of, I got tons and tons and tons of voltage gates. And if it gets there, those open, sodium rushes in, bada bing, bada boom, it sends that action potential. But it's just simply one little spot that's getting activated. But it would have to be something that would be a continuous impulse coming in, like the amount of light that's around us. Okay? The heat that we may be feeling. What does it mean to be spatial? Oh, they scored really high in their spatial abilities on the IQ test. Ever heard of that? Yeah. That's the only area I scored high in. And I'm like wondering, alright, I don't know if I can still do anything spatial. I reckon I can, I don't know. Alright? Spatial. In many different spaces. So, note that I might have just one action potential arriving, just one arriving, but because I've got it here, I've got it here, it could still be strong enough to cross the body, reach the axon hillock, and start my action potential. So, one spot, now two or more. Combine. Whoa. What in the world does that look like? Any idea? Looks like what?
Where before it starts writing the peripheral nervous system, one of the main nerves.
Okay, so we're doing it because multipolar is one of the most common. Okay? But do I see something where I've got both inhibitory and excitatory potentials coming in? So how do I know what's going to happen? Is this neuron going to respond or not? It's a matter of simple math. Who has the highest impulse? If it's more excitatory, it's going to respond. If it's more of the inhibitory, it won't. It's that simple. For the most part, a lot of what we're going to see in our central nervous system is going to be a lot of that, inhibitory and excitatory. Because what is the part of my central nervous system? My brain and my spinal cord. My brain. My brain. How many of y'all in here think? Huh? Love it. I try not to. But my brain kind of overrides me. How many of y'all have memory? How many of you can read, write, walk, run? You see where I'm going with this? When you get into part 2,